Okay, now we are recording. Thank you. So we are going to pick up, let me recap that for the video. We are going to pick up with the implementation of particle effects. Share my screen again. Particle effects into the game. So just something real basic that when the enemy hits our player, we get some sort of visual indication that some smackage has occurred. All right, so the way we do this, the way we create a particle is we're going to right click anywhere in the hierarchy and then go to effects and particle system. You can also, I believe, click here, go effects, particle system. I have no idea what particle system force field is, or I imagine a trail is like if you've got something where you want to, like you have a car and you want smoke to come out of the back of it or something like that. And then lines, is this like a line? There's a line renderer. Okay, line renderers are useful for drawing lines. I'll give you an example from ITCS football. Hold on. I use a line renderer for some things. But we are going to be working with just the basic, while that loads, just the basic particle system. So as soon as I click particle system, we say it right there. Let me switch back to ITCS football and I'll show you. So when you click to do a play and you hold shift, some lines draw on the screen showing where each of the players are going to go. You pause this while it's happening. These are lines drawn with the line renderer. You can see them right here. This is the line renderer, and lines get drawn on the field using that. Okay. Give me 1 second. Sorry, answering questions at the same time. Okay, so that's what line renderers are used for. Anytime you need to draw lines on the screen in world space or in 2D screen space, line renderers are the way to go. We are just going to look at a particle system. Okay, now, whenever you click on the particle system, so I'm going to drag our animator tab up here because we don't need it anymore. Whenever you click on your particle system, this is going to pull up this little effect window down here. So when I click off of it, notice it goes away and the particle effect stops. Only when I have it selected will it demonstrate what it's going to do. And that's simply just to save resources so you don't have it displaying all the time while your game's not running. On the right side over here in the inspector are all kind of values for adjusting what this is. Okay, this is a massive rabbit hole. Okay, don't mess with particle systems until you have time to mess with particle systems. Okay, you can spend days just messing around with all of the different options that they have here. A lot of cool stuff that you can do, but most of the time it's not. There are diminishing returns associated with the amount of time you spend here. My advice to you is Google a specific type of effect that you want and kind of copy the parameters that you find. Okay, so if you want some sort of snow or rain, or you want like blood splatter, something gross like that, there are probably preset ones that you can use rather than trying to figure out all of these values. There's probably also a lot of packages that you can download free, either through the Unity Asset Store or in other places that are pre-configured, ready to go for whatever you want. Okay. Now, what we are going to do is we're going to kind of set up just a very brief, we're not going to spend a ton of time in this, some sort of visual effect that occurs when our player gets smacked. Okay, when the rat hits the mouse, we want some sort of effect related to that. Okay, and so we don't. First thing is duration, and if you just mouse over this and then leave your mouse there, it'll tell you how long it lasts. So if we shrink this to 2 and hit it, it's going to decrease. So if I go stop and then play. Now, the reason it's continuing to do this is probably because we have it set to loop. Okay, so if we want to hit, that's a 2-second run. Okay, now if we want something short, like a burst, okay, now we have a start delay, start lifetime. Here's what we're going to do. Let's do red because red is like damage. I don't play. All right, let's take a look at shape. Now, for this particle system, we kind of want some sort of something to show in the direction of the mouse getting hit. So what this is doing is this is showing straight up in the air. Okay. And we want it kind of in the direction that the enemy is facing. So it kind of looks like something's coming out of his hand or whatever when he hits him. And so a cone is fine, but we do want to adjust the angle. Well, not that angle. Is it the arc? I think we're going to have to adjust the rotation up here. All right, so we'll leave this at 0. And then what we can do is orient it based off of the enemy. So if we have an enemy literally facing this direction, when we play it, it's going to come out that direction. Okay. Now, this max particles, we really only want 1, and you could do different things. You can do, okay, we want 10 particles, and then we want more of a, like a burst. What's this emission? Okay, so I'm just increasing the values. Okay, so here's a texture that we can add. We don't need. I don't want them to last that long. I don't think that's the value. I think we need to do. I'm looking for the value associated with how long they last. Not there. Simulation speed, space, gravity, colors. Short lifetime in seconds. Particles will die when its lifetime reaches 0. I would assume this would be it. Maybe I have to do like 0.2. Okay. So he gets hit. It's kind of too many particles, and we want to adjust the shape. So we'll make it more like this. That's too many particles. Do you see what I mean about how long you can spend doing this?
Absolutely.
All right, the last thing that we're going to do is we are going to do speed over lifetime. No, not size over. We want I want to slow them down. Force over lifetime. Velocity over lifetime. If I put -1, will that slow them down? That looks like they're going faster. Okay, that's about as much as we're going to do. I don't even know if this really affects it. You can see I am not an artist. I'm not good at this. Okay, we're going to stick with that because you guys get the point. Okay. You can mess with these values all day. You can add textures and do all kind of cool stuff to it. But that is not what we're going to do. Okay, so we're going to call this hit effect. And I'm going to turn this into a prefab. All right, so we're going to go, we already have a prefab for our rat. I'm going to drag and drop this here. We're going to go hit prefab. Okay. Then I'm going to go to our game manager, which I like having this at the top. And we're going to pull up the code for a game manager. So what I want to do is I want to create a reference to this so that we can instantiate it at runtime. Where's my code? Okay, so here's our here. So we're going to go serialized field, private game object, hit effect. Okay, save here. And then I'm going to drag and drop a reference to this so that we can, as needed, instantiate the hit effect. Now, I'm going to show you how to do this first, and then I'm going to show you a more optimized way to do this. So what we want to do is when we check for hit. Okay, so when we hit, what we want to do is we want to spawn this hit effect and attach it to the location where we are actually hitting the enemy or hitting the player. Okay, so we're going to go say instantiate hit effect. So we'll say game object hit effect equals game manager dot instance dot hit. I think we did serialized field, didn't we? This needs to be public. I'm making this public so that we can access it outside of there. Okay, game manager should hit effect. All right, and what we want to do is we want to instantiate this. So we're going to instantiate this. And the overloaded method that we want to call is this one right here. Okay, and so we want to put the hit effect at the location of the bad guy with the rotation that our bad guy is currently using. Okay, so we're going to say trans.position, and then we're going to say trans.rotation. So this is essentially going to take the bad guy's position and the bad guy's rotation, and we're attaching the hit effect to that position. Okay, now I think that's all we need to do. We go to our hit effect. I think there's an effect that removes it when it's done playing. Stop action. I don't know. Let's Google it. Okay, so I just Googled Unity remove particle effect when finished. Okay. Stop action. I guess you can select destroy and it'll automatically destroy it. Let's test that out. Okay. And notice when I did that, I clicked, you just edit it here, and then it's going to affect all of them when you do that. See, it says destroy. All right, so let's run it and see what happens. You know what? Let's spawn a bad guy and then wait 10 seconds before showing one. That way we don't have to wait 10 seconds the first time. Okay, so bad guy comes and pause. Okay, so we look here. We go, I'm going to go frame by frame. Right there. Okay, so we do that. We do the hit effect, and we see it spawn exactly where the rat is. Okay, and if we look, the rat's rotation. Actually, the right one. We don't want that one. The rat's rotation is Y155, and the hit is also 155. So if we watch how the hit plays, it goes directly in the direction that our bad guy is facing, which is exactly what we want. Obviously, it's at his feet, which is no good. Okay, and so we can do a couple things here. We essentially want it to match up with a part either on the player or the bad guy. And so we can do this one of two ways. One is we can kind of have a point on the player where we use, but I think a better option is to use a point on the bad guy. And so what we're going to do on our rat, so I'm going to go into our rat prefab, and on our bad guy manager script, I'm going to open that up. And what we're going to do is we are going to private transform. Well, right. We are going to essentially store the position of the hand. Okay, and so we're going to say right hand, because this is essentially what he's attacking with. If we were attacking with some sort of weapon, we would do essentially the point of contact there. So we save that, and then what we're going to do is we are going to go, we see it now pop up right here. We're going to drill down into the rig, which is the bone structure of the rat. And we are going to go all the way down to the right hand. Okay, so this is how the main thing is set up. Here's the root node. And then we have the left leg, and then the right leg, and then the spine. The spine is everything waist up. Okay, so neck, arms, back, everything is in the spine. So we're going to go inside of spine. And then we got spine 1, spine 2, and then we have left shoulder, neck, and right shoulder. Okay, so we're going to go into right shoulder, right arm. We go all the way down to the right hand. And we can just use the right hand. You can see they go into actual individual fingers and joints into fingers. Let's just go with the right hand. You could go with the middle finger. It doesn't really matter. If one doesn't look right, just switch it to another one. So we'll use the middle finger. And save that. Okay, then we'll go back to our code. And when we hit, instead of taking the position of the whole bad guy, instead of taking the transform of the bad guy, let's use that right hand dot position. Okay, and see if that gives us something that's a little bit more accurate. So run that. Bad guy coming at us. We should do this. Development tip, make sure when you're doing testing like this that you make your iterations as short as possible. Okay, so it took us 10 seconds to stop, move the mouse up. Stuff like that is going to add or save you so much time in the long run. Okay, so our bad guy's strolling in. He's getting ready to attack. Let's see if the particle effect looks any better after moving it to his hand. Bang. Okay, so we move it to his hand. Now, we did see that as soon as he hit, see our hit effect starts here. And then as soon as it completes, because we selected destroy as the stop action, it automatically goes away. Okay, now let's run it kind of full speed, see how it looks. Looks terrible. But we get the point. Okay, it's a little too long. Let's shorten it. Where is it? I just want like a red thing to pop up, basically. Maybe that's more gooder. That also looks terrible. But at least we see some sort of better gooder, more gooder. Okay, at least we see some sort of visual indication. And again, my goal with you for this is to simply show you what you can do and what's available, and then let you guys kind of take that knowledge and apply it as you need it for your game. Okay. Now, let's talk about efficiency. Doing it this way is not a super efficient way to do it. Instantiating is slow. Now, for a game like this, you're really not going to notice. And like even on a mobile game, you could do this and you would have no idea that you're instantiating. But my experience with game development, especially over like the past 5 years, has really forced / encouraged me to be more optimized with my code, especially when we ported Access Football to the Nintendo Switch, which is the world's slowest console ever made. Seriously, my phone runs circles around the Switch, and I've got an old phone. No joke, like my phone, I think this is a 12. I think it's a 12, an iPhone 12. What did they just come out with? Like the 14? Anybody know? Okay, 14. So my phone is 15 Access. Okay. I can run Access Football on my phone at much higher settings with features that I couldn't consider running on the Switch. All of that to say, I have looked much more into optimization and been forced to than I have in the past.
Is Access Football available on mobile?
Yes. Make sure you get the 2023 version and not the classic version.
Got it.
Which, side note, the last, and this is a point to the point I was just talking about. The last mobile version we released was 2019. We just released 2023, but when we released 2019, a lot of people still had older phones, even though I think at that point there was like 9 and 10 iPhones were out, 9 and 10. A lot of people still had 6s. I think that was still like the most popular phone, and the 2019 version wouldn't run on the older phones, and so we basically left the old version of Access Football on the app stores and renamed it Access Football Classic, and that's still up there now. because I couldn't optimize the game well enough to run on the old phones. Now, I have learned much more since then, and we could get it to run. But when you download it, and it's a free download, when you download it, make sure you get the 2023 version, not the classic version. I mean, you can play either one, but there's like a 6-year difference between the two games. More than that, I think. Anyways, back to optimization. Doing it like this, instantiating is slow, especially if you're instantiating larger objects. Something small like this hit effect isn't a huge deal, but it's not a good way to do it. Especially if we are instantiating over and over again, like bullets. If we're shooting bullets or paintballs or whatever, and we're doing like 10 a second, that's really, really going to add up fast. And it is not at all what you want to do. Do not instantiate that many objects that fast. What you want to do instead is cache them. How many of you remember your data structures class? That's not the confidence I was hoping for.
I do.
Did any of you have me for data structures? I think I stopped teaching that course by the time y'all came through. It's been like 5 or 6 years since I've taught it.
I took it in fall of 2020. So yeah.
All right. How many of you remember stacks?
I do remember stacks.
All right. Stacks are last in, first out. So like a stack of plates, you add one to the top, you remove from the top. So you add and remove from the top. Okay. And the idea is you use a stack when you don't care about the order of items. Stacks are great because they are really quick adding, really quick removing. Okay. And so what we want to do is we actually want to, when the game starts, go ahead and create a bunch of whatever object is that we're going to be instantiating and cache them. Cache is just a fancy way of saying create it ahead of time and store it somewhere until you need it. Okay. You want to be careful caching things because obviously it fills up your memory. So you never want to cache more than you need. But what this does is it prevents us from needing to instantiate the objects while the game is running, because we're instantiating at the beginning and then setting them off to the side and then pulling them from the cache when we need them and then putting them back in the cache when we're done. Okay. And so that's generally the way to do it. And so that's exactly what we are going to set up. Okay. So inside of our bad guy manager, and you can put this in game manager, you can put it in its own script. It doesn't really matter. But I am going to go ahead and I'm going to create a cache for our particle effects. All right. So let's see the best way to do this. I would come down here and I would actually make this static. And the reason we're going to make this static is because we're in bad guy manager. We're going to have lots of bad guys. We don't want a separate cache of hit effects for each bad guy. We don't want that encapsulated to our bad guy. We want one set of hit effects shared among all of our bad guys. And that's why we're going to make it static. So we'll say public static game object. No. Stack game object and hit effect cache. Okay. Now, when you took data structures, you probably weren't allowed to do that. You probably weren't allowed to use the built-in data structures for good reason too. And when I taught the course, I wouldn't let people use it because you needed to know how to actually code it so that you knew how it worked. Okay. A stack is a glorified linked list. It's simply, there's a pointer to the head and that's how you interact with it. And then each object holds a reference to the next object, which is how you create a stack. Okay. We're just going to use the built-in one to C#. And so when the game starts, I'm going to create a new stack. We'll just instantiate it here. It's like that. And actually, we should probably do this. That's fine. We'll create a new stack. Does this call it each time? I'm testing something out. Hold on. I want to see if each time we spawn a new enemy, if it calls start on that enemy. And so I put a print statement. Okay, it does. And so we don't want to create the stack in there because every time a new enemy is created, it's going to create a new stack, which is going to give us a fantastic memory leak. And we don't want that. So let's do this. I'm going to organize this a little bit because it's bothering me. Startup functions. Now we'll go. Nope. Update functions. This is typically how I organize. All right, so inside of this section, I'm also going to do public static void init. So we have an initialize function here where I'm going to create a new stack of game objects. Okay, and then from game manager, when we start this, let's make an we'll go like that. Okay, so this will only call it once. And again, because it's a static function, we're calling it through the class. And so that's going to call this right here. So only creating hit effect. That's going to ensure that it only gets done. So I think even if we did it on awake, I think it would. I think it would still call it. All right, so let's run it and find out. So creating hit effect cache in awake. In awake, yeah. It's gonna every time you respawn one or you instantiate a bad guy, it's going to call awake and start on it, which is not what we want. And that's why I put it in there, just so that we only call it once. Okay, and then say create and populate our hit effect cache. Okay. And then we're simply going to loop through, I don't know, let's create 10. Add hit text to cache. And then we'll create a private static void, add hit effects to cache. I'll show you why I'm separating this. Into a separate function in just a second. And that is not the key that I pressed. Okay, so essentially what we're doing here is I separated the actual adding of the hit effects to our stack into a separate function. And the reason I did this is so that we can call it again if we need it. You always want to do this. So generally, when the game starts, you populate it with an average number that you're going to need. Okay, it's like this should cover 90% of gameplay, but there might be like a small 10% chance where if we happen to have a ton of bad guys on the screen where we run out of hit effects. Okay, so you can do two things there. If you run out of hit effects, or if you're instantiating bullets, maybe you run out of bullets. There's a couple of things you can do. One, you can choose just not to show one. Okay, and you could say in your head, well, I've got 8 bad guys on the screen or 10 bad guys on the screen. The chances of the player notice that one of the 10 is not actually showing hit effect is pretty low because it's going to be like really clogged up on the screen. So I'm just not going to show it. Okay, that's one option. The second option is to add more if you run out. Okay, and so you would simply just call add hit effect to cache whenever you tried to pop one off and there weren't any there to pop off. That's what I'm going to do, just so you can see how it works. Okay, so we'll say add hit effect to cache. We'll say hit effect cache dot push, and then we'll say nope. I think we actually need to instantiate game manager instance hit effect. Okay, and that's it. Okay, now what we want to do is a couple things, and this does complicate it a little bit. We're going to go into our hit effect, and we're going to uncheck this. Where is the play on awake? Oh, right there, play on awake. I'm going to uncheck play on awake because we don't want it to play on awake. We want it to play when we tell it to play. Okay. And I am going to actually change one thing. The cache that we have set up here is holding game objects. I don't really want it to hold game objects. What I would rather it hold is a reference to the particle system, because what we're going to have to do is we're going to have to put it there, and then we're going to have to tell it to play, and I need to access the particle effect in order to do that. Wrong button. So I'm going to change this to particle effect, particle system, I think. And this to particle system, this to particle system. Remove this because that doesn't belong there. And so we're going to instantiate a game manager instance at hit effect. And then I'm going to say get component particle system. Okay, that was a lot. Let me break this into different things. Game object, so we'll say instantiated object equals okay. So this will instantiate or create a copy of the prefab that we have done. All right. We don't want the game object though. So instantiate gives us a game object. We don't want the game object. We want the component that's on the game object. We want the particle system that's on the game object that we instantiated. And so what we do is we are going to actually use the get component to pull the particle system component off of the game object that we instantiated, and that's what we are storing in the cache. Okay, does that make sense? Any questions on that? So that's what we're doing right here. And we're going to add 10 of those to start with. Okay. Questions on that? Any questions on this? Okay. So now when we come down here, what we're going to do is we are going to say hit effect cache dot pop, and that is going to give us a particle effect, particle system hit effect. Okay, everybody good with this code? This is going to pull, not pull, pop. It should be pull. Adding is pushing, removing should be pulling, but somebody called it pop. Who would do that? Anyways. So now we removed and have access to the hit effect that we popped up from the cache. Now, what we're going to do here is make sure we have a hit effect in the cache. Okay, so we can say if hit effect cache dot count is greater than 0. Okay, or we can say if it equals 0, then we are going to add hit effects to cache. Well, we'll add 5 more if we run out. Okay, then we will instantiate the hit effect. What we'll do here is we're going to take our hit effect dot game object. So that kind of goes in reverse order. It goes from the component to the game object. So now we get access to the game object itself. Dot transform dot position equals right hand dot position, and then we'll say hit effect dot game object dot transform dot rotation equals trans dot rotation. Okay, now let's comment this. We'll say put the particle effect on the bad guy's right hand, and then this will say orient the particle effect to the bad guys forward, or bad guys orientation. Okay, questions on this code? Any questions on this code? Okay. We save this and run it. Okay. So, several problems. One, we aren't actually seeing this. Who knows why we're not seeing it? I said it a minute ago. Need to tell it to play. Because remember, before we had it playing on awake, but we instantiated it, then we attached it, and now we need to tell it to play. And that's exactly what we're doing. Okay. Now, there's one other issue with this. Who can tell me, like big picture wise? And here is some advice to you while you think about what's wrong with this. Whenever you are doing things in your code, it's a good idea while you are setting up those systems to put in print statements to notify you when certain things are happening. This will prevent you from making mistakes and having your code do things that it shouldn't be doing. Okay, so watch this. I'm going to put in a code. We're going to say adding hit effects to cache. Well, adding quantity to add hit effects to cache. Okay, so this will tell us we're adding hit effects to cache. And then I'm going to put one here, ran out of hit effect. Hit effects in cache. And so let this play for a little bit. Okay, so it starts and we add 10 to the cache. That's good. That's what we want. Okay, we hit, we see it show up. Everything's good. We're getting no messages. This is what we expect. Okay. Uh-oh. It says we ran out of effects in the cache. Why did we run out of effects? We're only showing 1 or 2 at a time, and we had 10 in there.
It's because with every enemy you spawn, it's decreases the effect somehow. Well, no, it decreases like the number of the amounts that can be in the cache. Or is that completely the opposite?
No, it doesn't affect the number of cache, the number of effects in the cache. But the idea is here, we're creating a loop, right? Okay. Yeah, so 2 things. One, as Thomas pointed out, they're still set to be destroyed when they finish. Okay. And so we'll go hit effect. We want to say not for them to be destroyed at the end, but big picture wise, there's a loop that we should be creating here with the use of these particle effects in the cache. The idea is when the game starts, we create a set of them. We create 10. And each time we use one, according to the code, we are going to pop one off of the stack, use it, and then what?
Put it back in the stack.
Perfect. Yeah, we need to put it back in the stack. Do we ever do that in code?
No.
No, we never do that. And so we've got an open loop here, and that's not good. We add a bunch and then we take them off, but we never put them back, which is why we ran out after we used the first 10. Okay, and so Thomas is absolutely right. We've got to first tell it not to destroy when we finish, but more specifically, the stop action we want to call back. Okay. And I have no idea how to use this. But we essentially want to call a function when this is finished. So we're going to go back to this and we're going to say unity particle effect callback. And we'll see if we can figure this out. Anyone know how to use the stop action callback? All right, here's the docs. On all scripts attached to the same game object. Okay. So if we look at this right here, what's happening is, I know this doesn't give you guys a lot of information. Here's what this actually means. So mono behavior is the class that all scripts inherit from in Unity. Okay, so if we look at this all the way up to the top, this is inheritance in C#. This means bad guy manager inherits from mono behavior. Okay, so when you use update, awake, on collision, enter, that sort of thing, those are all inherited from mono behavior. And so what this says is, this gives us access to a script called on particle system stopped on all scripts attached to the same game object. Okay, so all we need to do is we'll save this, or we're in hit effect. What we need to do is we need to add a component, and we'll call this hit effect. Okay, we're going to add a component, which is a script called hit effect. I'm going to take and drag and drop this inside of script, stop popping up. And we see right here, now we have our hit effect script. Okay, so we're going to do a couple things. I'm going to change this code around a little bit just for the sake of a couple things. Let's simplify things a little bit. So I'm going to go and I'm going to get rid of this initialize method from the bad guy or from the game manager. So we're going to do it a different way. I'm going to get rid of this altogether. So here we have this add effects to cache. And what I'm going to do is inside of this, anytime we want to add an effect to the cache, we are going to call this method. And so it's easy just to put a little check right here. If hit effect cache equals null, meaning we haven't created yet, then go ahead and create it. Okay, does that make sense? Any questions there? Okay, that way it removes the need to use an initialized method from another script. Simplifies our code a little bit. Okay, and then what we're going to do here is we're simply going to add a hit effect. Hit effect. Okay, so whenever we do this, we are going to pass in a reference to the hit effect. Okay, let's come over here to this. Stick with me for a second. So we have our hit effect script, or excuse me, our hit effect game object, and on it there's a particle system, and then there's there was a script. Where's our script? Oh, we didn't save it yet. There it goes. Our hit effect script. I'm going to move this up to the top. Okay, it doesn't matter where it is, it's just easier for me to see up here. So on our hit effect script, I'm going to do two things. I'm going to say public particle system. I'm going to get a reference to the particle system. This will prevent us from having to use get component. Okay, so we see this pop up here. We have errors in our code that it doesn't like. Let's comment that out for now. Okay, so now we can drag and drop onto our hit effect script a reference to our particle system. So, and the reason I'm doing that is now we can access our particle system from the hit effect script without having to use get component on the game object. Okay. Save that and go back to our hit effect script. Okay. Now, what I'm going to do here is I'm going to say private void start. When this first gets created, what we're going to do is add this to the cache. All right, and we can, so it's going to essentially add itself to the cache. All right, so we're going to say bad guy manager dot change this to public static void add effect to cache, passing in our reference to itself. Okay, because it is a hit effect and our add effect to cache expects to receive a hit effect. Okay, if the cache is null, meaning we haven't created it yet, go ahead and create it. And then all that we're going to do here is we'll say hit effect cache dot add, or sorry, dot push hit effect. Okay. Now we do need to change the stack, not to hold particle effects, but to hold hit effects. Okay. I know I changed a lot of code on you there. Is everybody good? Did I go too fast? Okay. So that brings us down here. So when we go to use it, we need to, and we'll get to this in just a second. So we're going to instantiate the effect, which we need hit effect. So we'll say hit effect, we'll pop it off, and then we'll say hit effect dot transform. Okay, and then hit effect dot particle system dot play. Okay, because the hit effect particle system, sorry, is stored right here. Let's go back to here. And then we still need here, we're going to go create let's call it create hit effects. We need a way to do this that's separate from the bad guy start. So I think we will need that initialize after all. So bad guy manager dot, and then I know I took this out, but we need to add it back in. This is coding off the top of your head. Public static void init. And we can go ahead and do this here, so we don't have to check every time. And then we'll say populate hit effect cache. All right, so we'll say hit effect. No, we want to say instantiate Hit. Nope. Where are hit effects? They're in game manager. That's it. So instantiating them will automatically call the start. Okay, to automatically add it to the cache. Okay, so let's make sure this all works before we go any farther. All right, well, let me add some output messages to this. All right, so we're adding 10 hit effects to the cache. That's what we want. We expect these to show up when we hit. They do. Okay, we also expect to run out at some point. Okay. So in the interest of time, I'm trying to go a little quick. So we come down here. This would still populate. And so what we can do is we can just add more. We'll just add 5 more if we run out. That should never happen, but before we actually write the code to add them back to the cache, let's see. So this is 9 we have left, 8, 7, 6, 5, 4, 3, 2, 1. Then we should be out right here. Okay, and we are. And so right here, you see we got an error because we ran out. So we populate the hit effect, we're adding 5 more. And if we look at so we ran out of objects, we're adding 5. And looks like this is not good because we shouldn't ever get an error.
I think the stack emptied before we could refill it.
Yeah. Well, here's what's happening. When we get down to 0, we add, and the idea is that we're adding more right here before we pop. But the problem is it takes one entire frame before the ones that are being created here actually get added to the stack, because we don't add them here. Okay, they don't get added here. They get added once they appear and the start function gets called. And so we could simply say something like, if we're less than 2, like, okay, we're getting close, or we'll say almost out of hit effects in the cache. What this does is this gives us a tiny bit of breathing room. If we get low, then we'll create them. Seven, 6, 5, 4, 3, 2, 1, 0. Okay, so this, just gonna let this run for a minute, just ensuring that we never are crashing. Okay, and we're okay. Okay, now let's go to hit effects, and as our handy dandy internet told us, we can do public void on particle system stop. Okay. So this should get automatically called when our particle system finishes. So we should see it get called now. Okay, which is exactly what's happening. That's perfect. So all that we're going to do here is add the effect back to the cache. That's it. Remember, this doesn't create a new one. It simply adds it back to the cache. So we run it. And see, it's hard to tell here. So what I'm going to do is this. inside of bad guy manager, when we go to do every time we try to use one, I'm gonna say number of effects in the cache equals hit effect cache dot count. I'm pretty sure for the first one it should stay at 10. So it was 10, still 10, because it's getting added or getting removed and then added right back as soon as it finishes. So we might see it pop down to 9 here. Doesn't look like it. All right, and we see now it pops down to 9 because before the first one can get added back, we're using another one. You see now we're kind of down to 8. All right, so look at this. What we see here with these clones is no more are being created or destroyed. Okay. Where before what was happening is they were getting instantiated, destroyed, instantiated, destroyed. And all we're doing here is essentially turning them on and off and reusing them. And you can see here, like, sometimes we dip down to like 6, but because we're reusing them, we don't ever run out. Okay. All right, questions for me on this? No questions.
At what point would the cache like finally run out? Or does that just depend on your machine?
No, it doesn't depend on the machine. It depends on how many bad guys there are and how often you're using them. So what would happen is at some point it would dip down to below 2. And what we could do here, like watch this. So add effect to cache. Adding effect back to cache. Size is now. So whenever we remove one, it'll show us the count, and whenever we add one, or whenever we add one back, it'll show us the count. Okay. So, well, let me do it this way because it's showing after it's showing before we add. And let me. Removing hit from cache. Okay, so whenever we remove one, it'll tell us, and whenever we add one back, it'll tell us. Okay, so we've got 10 in there now. Now we have 9 and then 10. You can see like how long it takes for it to get added back. It's pretty quick. Okay, and so now when we add 2, what's happening is it's really reusing the same one. Okay, because it's able to add it back fast enough. And you can see now we're actually popping down to 8. Let me remove this player is dead. Because we just want to focus on the hit effects. Okay. And what you'll see is whenever we drop below 2 and we add more, it's going to really pick up. And then once we kind of run away, you'll see it bounce back up to 10. Or 15 in that case. All right, so the lowest we get right now is 8. And it's going to take several enemies before we run out. Because essentially what has to happen is we have to basically use all 10 at the same time, because it's like a fraction of a second. I think it's like what, 0.25 seconds, the amount of time it actually stays on the screen. And so after that 0.25 seconds, it gets added back to the cache. So it's gonna be really hard to exhaust what we have. The lowest I've seen it so far is 7. This is why this system is so good, because you can imagine how many we would be instantiating all at the same time. We get down to 6 yet? I think I saw 5. So again, remember, I don't know how many bad guys we have, 20 or so. We only have 10 hit effects. And because we're reusing them in this way, we're really only ever using like 3 or 4 at a time, which is crazy when you think about it. Okay, and that's the benefit of this system. Like we're nowhere even close to running out. So in the interest of time, where's our game manager? We're going to spawn a bad guy every half second and just see what happened to our code. Oh, well, that's why. That's a lot of bad guys. But we got down to 3 at one point. I saw it.
I think we got down to 2 at one.
Yeah, I saw 1 not too long ago.
So we should have more than 10 in there. How come we didn't add more? Oh, there you go. So now our cache is up to 30. I don't know how many bad guys we have. It's a lot. Okay, and you see how the system is flexible. We've got so many on the screen. Now we've got 50, and we still never ran out. Like no, now we're up to 80, 85. Just imagine how many instantiate calls would be happening if we didn't use this. Now, granted, this isn't a normal situation, but it does show you the power of this system.
Well, you're going to add, so yeah, we're going to add colliders to the enemies at some point, or at least give them like some sort of rigid, if not rigid body, at least like make it so they're not like morphing into each other.
We could. Depends on the game. Most games
Yeah.
don't have colliders on people. But
that doesn't mean people go through like other people and other objects and stuff.
Yep, absolutely. It just kind of depends what you want. But all right, we're out of time. I'll make sure this gets up on Canvas so you guys can refer back to it.